Thermal imaging cameras are a must-have tool for any electronics lab. I'll show you a tip to improve performance when troubleshooting PCBs. Now, most thermal imaging cameras like this one are really designed for surveying things like houses, things from a far field. If you want to diagnose PCBs at the component level, i.e. you see the dissipation of individual components, it's quite tricky to do as standard. However, you can make a fairly simple modification that gives you pretty good results and make these really useful for component level repair and troubleshooting. So the problem with these is the focal length of the lens. What you really need is an additional optic to allow you to get much closer macro shots of PCBs. Now, what I've got here is a zinc selenide lens, typically used on Chinese cheap CO2 lasers and more expensive ones, but this is a cheap one. They're also used on thermal imaging cameras as well. Now, this particular lens here is a 20mm diameter with a 2-inch 50mm focal length. Now, what's special about these particular lenses is they are transparent at long wave infrared wavelengths, such as those emitted by these cameras. So you really need a lens that's transmissive at those frequencies. Now, what I've got here is a 3D printed lens holder. This particular one I didn't design, it was available off the internet. Many people have made their own 3D models for many common cameras. I've got here a HIC Micro B10 camera. It's relatively inexpensive and you do get great results with this. So let's go over to the bench and have a look and do some comparisons with and without and see what performance we get. So I'm sat at the bench now. I've got a PCB powered up, just looking at the underside of the board here. Now if I take the thermal imaging camera, which is set to the macro mode, you can probably just about see there that there is, you can see the sort of thermal variance across the board, and there is a little bit of a hotspot around this area, but we just don't have the focal length to really ascertain exactly which components there are dissipating the most power. I've now taken my zinc selenide lens, fitted it to the 3D printed mount. I've just crudely taped it here just to stop it falling out. One thing you do have to be careful about with these lenses is they do scratch easily. So bear that in mind when you're looking at things. So if we take the camera now and look at the board, you can see we get a much better image. And we can actually see we've got two individual hotspots here. We've got one here and one there. You get much better clarity of the board. The parts we were just looking at there are these two very small DFN packages here. You can see actually next to them you've got an 0603 capacitor. They're actually smaller than that. So as you can see, they're a great tool for diagnosing boards. They're particularly good at finding shorts on PCBs. If you ever had a shorted component and you just don't know where it is, these can save a lot of time in tracking down those shorts. They're particularly useful for finding shorts in things like multi-layer ceramic capacitors. I've certainly used this tool before for finding those faults, and it's proved very handy. So I hope you found this video useful and of interest. Thanks for watching.